In this module, we'll talk about time value of money. This PowerPoint is a supplement to the additional reading material posted on time value of money. It is a chapter from a different textbook that discusses time value of money in detail. Please read and study that chapter, and this PowerPoint will help you supplement and or complement what is in the chapter. So what I want to do is to go through the basic concepts of time value of money and then do some examples, and those examples you should try to replicate them on your own. You can stop the video and take notes and practice, and there are assignments posted for doing the time value of money concepts. So let's start out with how we're going to apply this thing. When we discussed in the earlier lecture what I was talking about the net worth, I used this hypothetical situation, Judy's balance sheet and income statement, and we talked about her financial assets, and also talked about her salary and so on. And so typically for anyone, there could be, situation could be different for each person. But what if we want to try to forecast what the amount will look like in the future? And that's where the concept of time value of money comes in. Time value of money concept is critical, is a fundamental to investment strategies. There are parameters that we will be using multiple times during the semester, so it is extremely important that you get very comfortable with this concept in this week. Practice the problems I'll giving you on this PowerPoint video, and also do the assignments that are also posted. So let's start with time value of money. So time value of money, if you really think about it, it has you're starting from today. That's called the present value. So the present value is how much we have in number. A number could be what is my salary today, and what do I estimate it to be, say, 5 years from now. And so N will be 5 years. N is number of periods. The next thing is to say, okay, what am I estimating my salary to grow over the next 5 years on average every year? That will be the growth rate. So let's say if I think it's going to grow 4% a year. So now if I know my salary, let's say it is $70,000, and if I multiply that by 1 plus 4%, that would be 1 plus 0.04. Percents are always, in 4% means 0.04, 5% means 0.05, 6% means 0.06. And then we compound it for a number of years, which means you take the amount of the salary times 1 plus 0.05 or 0.04, and you do it 5 times. Or you can go in and do this calculation, 1 plus the growth rate, and you raise it to the N on your calculator or using Excel, and that will give you the future value. We can do the same thing if I have the future value. If you want to figure out the present value of the amount, we take the future value and you divide it by 1 plus, again, the growth rate or discount rate, and you raise it to N. So these concepts will be used quite a bit in our class, and including this particular week 1, where you will be applying this thing using the formulas and the Excel. So when you're thinking of time value of money concept, there are 5 fundamental parameters, or I like to call ingredients. And those ingredients can be put into different formulas, or what I like to call recipe, and we can decide, depending on the recipe, what are we trying to figure out. Then we can apply those formulas in. The 5 are: 1 is the present value, which is the amount today. 2nd is the future value. What will the amount be in the future? 3rd will be, what is the time horizon between the present value and the future value, number of months or years, which is N. The 4th one is the growth rate. How much is it going to grow between now and the future value in terms of average per year. And the fifth one would be, what if we are also putting in some amount every period in addition to what we have today? You know, a typical example would be if somebody has money in a 401k or some kind of an IRA, they may also be additionally putting in some money every year. So we have to also, you know, figure out how to calculate that. So, for example, let's say somebody has planning to put money in every year. In year 0 now, they want to put in $2,000. The next year they will put in $3,000. The following year they're going to put $4,000, and the next year they're going to put $5,000. And their plan is, by the time they get to the T3 or this year, they want to have money to do something with it. You know, something could be retirement, something could be they need money for a down payment, something could be they need money for college tuition. So how do we calculate how much it would be worth? Obviously, two things we need. One is how much, three things we need. One is how much money we're putting it in. Two is how long, how many periods it's going to compound. And three, at what growth rate. So let's say somebody takes $2,000 and puts it into some kind of a CD that gives 5%. So this $2,000 has got 3 more years left to grow between now and the time this person wants to, take the money out. So $2,000 will grow one times, and we're going to compound 1.05. It's growing at 5% a year. 1.05 3 times, or we can take 1.05 and raise it to 3, and we'll get $2,315.25. The next year, person is putting in $3,000. It's got only 2 years left to grow before they're going to take the money out. So $3,000 will grow for 2 years. You can take 3,000 times 1.05 twice, or 1.05 raised to second power, and you will get the 3,307, 4,000 the following year. It will only grow 1 year, and so on. So from there you can see how the calculation would be done. Now, another example would be, what if the numbers are same? And that gives us a feeling for a calculation to see how the compounding really matters. So $1,000 put in T1 has 4 more years to grow, from T1 to T2, T2 to T3, T3 to T4, T4 to T5. It's 4 years compounding. So $1,000 put in T1 will grow 1,000 times. Let's say this one example is a 6%. 1.06 raised to 4, or compounding it 1.06 4 times, and you get 1262. So as we have less compounding, we will see that the numbers are obviously growing less. The next year would be 1191, 1123, 1006, and so on. So this is where the compounding effect comes in. The other thing is, from a calculation perspective, if we want to find out if we are putting in the same amount of money like we did in this example of $1,000, if I want to figure out the future value and not have to go through each step like we did over here in a prior page and also shown on the bottom of this page, we can do the calculation in one shot, as long as the amount of money being put in every period is exactly the same. That means there is no period where the number is either 0 or slightly different. So the number is 1,000. We put 1,000 over here. Now, from a basic algebra, just a quick refresher, I'm sure all of you know. When you have a formula, what you want to do is to first calculate the numbers that are in the parentheses. So in this case, R is 6%, N is 5. So you'd calculate 1 plus R, so this would be 1.06 raised to 5. You calculate that number. Then you want to finish calculating the numerator. You subtract 1 from it. Then you got the numerator done. Then you divide it by the denominator of R, which is 0.06. Once you have that number, you multiply that to the PMT, which in this case is 1,000. You get the future value, and if you do the calculation, you will get 5637.1 as shown on this one. Okay. Now, for this class, we will be using Excel. But the reason it is super important to understand the concept, at least you get a feel for how the numbers would change. What do I mean by that? For example, here you can see that if I want to increase my future value, how much money will I have? The levers I have, or the ingredients I have, is either I can go in and put more PMT per month from my 401k, or if I keep it longer, N should be higher. Instead of 5 years, leave it for 10 years or 20 years. Or if I can, if there is an investment where R would be a little bit better, Instead of putting the money under the mattress and having no return, have some return. So obviously R, higher the R, higher the N, higher the PMT, more future value you will have. Okay. So we'll use Excel. In the Excel, we'll be using the formula. How will we get to the formulas for Excel? You will go to the formula tab, and then you're going to go to financial tab, and then you're going to go down and you're going to click it, and then you're going to find this formulas. So this is a screenshot. So what I will do now is to do some examples, but I will use Excel so you can see how to use it. Okay. So let's say a person has a salary of $70,000 today, current. That would be the present value, and they think that their salary will grow about 4% a year. How much will they have in 4 years? If you do the calculation, you're going to 5. Then and in 5 years the salary will be up to $85,165, and the 10 years will be up to $103,617. And similarly, what if we say, well, what about the inflation? How much will the money really be worth if I account for the inflation? Let's say the inflation is about 3%. So in that case, if the expected growth is 4%, inflation is 3%, that means the money is only going to grow 1%, 4 minus 3. So money will grow, but not as much. So even though the salary at that time will be $85,165, it will feel like you have $73,570. Why? Because of the inflation, your buying power will be less. Similarly, in the 10 years, the salary will be $103,617, but the buying power would be $77,323. So let's see how we do this in an Excel. Okay. So what we are going to do is, I'm going to clean this thing up so we can do the calculation. Clear content. So first thing we want to do is to set up the Excel so we can put the numbers in. Okay. The current salary, we're going to put the number, we write down 70,000, so we're typing it in, that's the number we put it in. We put in the growth rate, which is 4%, so the 0.04. So those numbers we're putting it in. Okay. Now we want to do is to find out for 5 year, so we put in 5 here, 10 year, we put 10 year over here. How much will the number be? So this is the formula that it calculates. This is the formula it's calculate. Now to show you how I am going to do is to do it again, but this time we're gonna put it right here, and let me clear this too. Okay, so let's say I just make some room in here. So let me just insert some rows. Okay, so here we go. Now, so I'm going to calculate this number. What would it be at 5 years? So first thing you do is you go to the cell where you want the number to be calculated. You go up where the formula is. You go to the financials. Now we're going to find the future value. So you find FV, which is right here. So this table will open up. Here you have to put in information so Excel can calculate it for you. The first thing you have to do is to say, what is my growth rate R? Now you will not type in 0.04. I mean, you could, but that's not a very efficient way to do it. What you want to do is to go in, click the cell the number is in. So I'm going to click this cell, as you can see, which is B5, which means is column B and row 5, and it picks up, so we'll know where it is. Then it wants to know is how many periods, how many number of periods you want to calculate it for. Well, we first want to do the 5 years. So I go to this, click here, and it'll pick up, as you can see, C3 over here. Then he wants to know is to say, okay, are you also putting in is there any PMT? In this case, the answer is no. All we have is the present value, which means how much is the amount today. Well, the amount today is this cell, so I'll go there, $70,000. But in this case, what you want to do for the time value of money, you want to do is put the present value in, and you click OK. Okay, so the number you're gonna get is 85,165. Now don't worry about the negative part. The time value of money. The reason it is the way it is that time value of money logic is that when you put money in, you're basically giving it up. Okay, and when you take the money out, it will be positive. So the absolute number will still be okay. So if you get a negative number, I wouldn't worry about it. So now let's say if I want to do this one. 10 years, same thing. I go to the financials, go to the future value. Rate will be this cell. Number of periods now would be 10 years. I'll go over here. Present value will be 70,000, and I get this number. And again, don't worry about the negative part. Now, the reason for using Excel is, what if you say that, okay, what if my salary instead of 4% can grow at 4.5%? So I've been 0.045, and you can see, you can easily calculate what the number would be. So it is really, really important to do that. Now, what if we say, well, so I'll go back to the 4% for right now. Now the question is, somebody said, what about the inflation effect? You said the inflation effect is there. The answer is yes, it is. So let's say if I come down over here and I said, okay, salary is 70,000. I'm expecting my salary to grow at 4%. But the inflation is about 3%. So what I really have a net is 1%. This cell minus this cell, I get this cell. So this time around, if I want to know what would my buying power be, that means what would the equivalent salary be, even though I'll be making 85,000, what will it feel like as far as my purchasing power? So we could do the same thing. Let's say if I come over here, I go to look at the future value. R in this time will be this net number. So I go here. Number of periods this would be 5. And future present value is still that. And I will get a number. And obviously it will be less. Why? Because of the inflation effect, which means salary will be 85,165, but it will feel like 73,570. So here's another example of how time value of money could be used. Okay, let's do some more examples. What if we now want to see is to say, okay, what about forecasting somebody's portfolio? Okay, let's say Judy has $50,000 in her account, and she does not add any more, just in this example, and she wants to know in 20 years how much will she have if the money grows at 3%. If we go through the calculation with Excel, which I will do to show you again, you will have 90,305 in 20 years. Now again, if you adjust for inflation, which means inflation is 3%, the money really will not grow at all. Why? Because whatever you're going to, even though the money will be 90,305, it will feel like 50,000 because everything would be a lot more expensive. What if we say that, if somebody invested in some place and they made 7%, what would that number be now? Well, the 50,000 then would be 193,484, and again, adjusting for inflation would mean that instead of growing at 7%, it will grow at 7 minus 3, 4%, and that's what the number would be. Okay. Similarly, what if we say that, okay, what if she has 50,000, but she also wants to add some amount every month. And let's say she's putting $420 every month, so over the 12-month period, she's putting in $540 every year. So now she's adding more money. How much will she have? So now, at 3%, she'll have $225,000. Obviously, 50 grew, and so all this money she's putting in every year is also growing too. If I adjust for inflation, it will be $150,000. At 7%, the number would be 400,000. Adjusted inflation would be 259,63, 637. So again, here is another example how time value of money is used. If somebody has money in their IRA or 401k, and they decide to put some money in this example, we're putting in 5,000 every year. Somebody can put in 1,000, 2,000, whatever. And you can figure out what the amount will be depending upon what your assumption is for what the fund growth rate will be, and for how many years, in this case 20 years. So now let's go look at the Excel again to do this one. So let's be starting with, let's say the first one we are going to do is first one we are going to do is, what if she is not putting any money in? So the way we set this thing up, we say, what's the current value? She has 50,000. How much is she going to put in every year? Right now we're going to say it's 0 for the first example. And let's say she is going to make 3%. In 20 years, her amount will be 90,305. Now how do you do the calculation? Well, I'll do it right here again for you. Go here. We're going to go to the financial. We're going to see what the future value is. We need to know the R, which is this cell over here. We need to know number of periods, which is this cell over here. We are not, PMT is this cell over here. Even though it's a 0, we should put that in cell in there. Present value, this is where you want to, when you're doing it, you notice I have minus sign up here. And the reason the logic is for investment time value of money is you're putting your money in, which means you're giving it up. So that's why it is negative. And then you get it back, that's a positive. So anyways, you just plus that cell over here, and you get 9305, okay? Now the beauty here is we can do very easily, what if the expected return is higher, let's say it is 0.07, I can just change that cell and I get the number. What if I decide to put in, you know, let's say in the other example we were saying it's 5040. If I do that, I get, you know, boom, I'm sorry. Again, we're going to put a minus sign in there because we're putting money in, so that should be a minus sign. I will get 400, you know. So the takeaways are this. You're going to use the formula. Money you're putting in, which is your money you're investing and you're giving it to your investment planner, or you're putting in the IRA, should be negative. Any additional money you're putting in should be negative. And then you get a positive on the other side. So again, what if I want to do is to say, well, what if I, instead of 20 years, I wait for 30 years? You'll have $856,000. Why? Because the compounding effect makes a big difference. And so this is how the time value of money can be used to figure out what the portfolio will look like in the future. Okay. Now, we'll do one more example by Excel, and the other ones I will just show you the answers, and I want you to go try to do it on your own as a practice, because you have the answer, you should be able to get to it, and then obviously you also have to do the assignments on your own where there are no answers. So let's look at one more. I will actually do a couple of them. We'll do this one and we'll do one for the mortgage. So in this one, let's say somebody is in the process of deciding how much money can she have from her portfolio if she's, you know, let's say she's going to retire, and she, you know, so let's say she has $400,000, okay, and what she wants to know is how much money can she pull out over the next 20 years, assuming that she invests in some fund, keep it a little conservative, so that makes about 4%. So she has $400,000. If she invests in a fund that will give her 4% a year, and she wants to know is over the 20 years, how much money will she be able to take out of this fund, such that at the end of 20 years there will be nothing left. So the calculation basically will be the portfolio value is 400,000. Your return you're making is 4%. Years is 20. When you do the calculation, you'll get 29,432. So how we do with the Excel? So again, over here, we want to do is money we are putting it in or giving it to an investor, we should make that as a minus sign. Okay. Sorry. Minus sign. So let's calculate it now over here. Okay. So we're putting in minus 400,000, giving an investor, and the investor is gonna give us how much every period. So we're gonna go here. We go to the formulas, go to the financial formulas. This one, we want to know the payment. How much money will we get? So that's a payment. And again, a lot of this stuff is also in the chapter that I gave you to read. So PMT. Again, first thing is R. We go here, click that cell. N is 20 years, click that cell. Present value is this cell over here, and we click. That means that this person will get 29,432 every year, which means that if the fund grows at 4% a year and she's taking money out 29,432, this money will last her for 20 years. Okay. Now, what if she says, I want it to last for 30 years? Suppose she thinks that maybe she might live a lot longer than 20 years from her retirement. So 30 years, we change the number from 20 to 30, and obviously If money to last for longer, she will have to take less out. In this case, she will take out 23,132. What if she says she's going to live 40 years? Obviously, the number is going to be less. She can pull out because the money has to last a lot longer. So you can see how time value of money can help in terms of some of the planning process. Okay. This one, I want you to do it. Try to figure out how you would do it. Kind of learn with Excel. You may have to Google. You may have to read an Excel textbook or whatever. What I want you to do is to say, and I'll give you the answer. What I want you to do is to say that this person has $400,000, and she gives it to bank, but she's got someplace very, very conservative, making only 2%. But she needs $29,432 to live. I mean, that's the money she needs to live on, and that's the amount of money she needs minimum. So the question is, if the fund makes only 2%, how many years will it last? And the answer is 16 years, but I want you to be able to make that connection and do the calculation. Okay. Let's do the mortgage calculation. Mortgage calculation, obviously a time value of money concept. In this case, we are basically borrowing money today, and we have to give this money back to the bank over the next, say, 30 years or 15 years, depending upon the type of the loan. And the question is, what would the monthly payment be? So let's say somebody is borrowing $150,000. Let's say interest rate is 3.5%, and the term is, say, 30 years. How much will they have to pay every month? Combined principal and interest would be $673.57. So over here in the Excel, we would have the loan amount. We'll have the interest. Now, in this case, because we're looking for a monthly payment, what we want to do is to write down the interest payment, which is 3.5%. Then we also want to do is to calculate the monthly rate. That would be taking the annual rate of 3.5% divided by 12, and that's the number you will get. Same thing with the term is 30 years. We want monthly payments. So we take 30 years, and then we multiply by 12, we get 360 months we're going to pay. We do the calculation, we're going to get 673.57. So let's do the calculation. So we want to do is $150,000. Okay. So we are going to do this. With this, let's say I'm going to calculate over here. I'm going to the financials. We want to know the payments, how much payment we'll have to pay. So go to PMT. PMT, right here. R, again, we want to use the one that we just calculated over here. Remember I said we had this number divided by this number, we're going to do that. Number of periods, we're going to go to the month, 360 months. Money we are borrowing is this amount. And if I want to be exactly what I had in the PowerPoints, we said over here is going to be 3.5%. So you can see the 3.5%, this number is really nothing more than taking this cell, which is B5, B again column and 5, divided by 12, you get that number. Term is 30 years, term in months is 360, which is basically taking this cell, B8, and multiplying that by 12, so you get 360. And when you do the calculation, we get $673. Now, the value here is, what if we said suppose I want to borrow more money, can I afford it? If I go 200,000, obviously the amount will go up to 898. What if the interest rates go up to 3.7? We can do the calculation. So this way you can kind of play with it and it'll do it for you. So this is another example, but time value money is important for when it comes to investment strategies. Okay. Similarly, here is another example where what if we take Judy and say, okay, what if we want to try to figure out how much money will she need to live off in the future? Okay. So right now she spends about $3,052, which is in the red over here, and a lot of her fixed cost. And another $1,475, and her variable cost that would include grocery, dry cleaning, eating out, gas, so on. So if I take it on the left side, so her fixed cost is $3,052 and her other expenses is $1,475. So right now she needs about $4,527 to live off. But then you can say, well, maybe by 20 years she will have paid off her student loan and her equity loan, so let's say we don't need that. But right now she has got health insurance from work, so she may have to pay for it. So that would have to be added to it. So now her total monthly will be minus 440. Or if I do that by year, she will need $53,280 money to live off. Okay. Now that's today. In the sense of today's dollars, that means that's a buying power today. If I account for the inflation and everything is going to cost 3% more in 20 years, this would be equal to $96,229. Why? Because of the inflation, that amount. And that's why even though what we live off today is what it is, as the inflation, the gallon of gas, the gallon of milk, our utility bills, everything will be up, on average about 3%, so we'll need a lot more money. So when you're trying to do your investment strategy to see how much money you will need when you retire, you also have to figure out how much money will you need to live off, adjusted for the inflation. Okay. So what is the so in this example, I just kind of used this number over here, and I said, okay, that's what it is, and this is the variable cost, and so that would be some of the examples you can apply. So I hope this is helpful. I am going to now close this thing and